Okay, hi everyone. Today we're going to solve this problem that is LeetCode 6 zigzag conversion. It's a very classic problem, and as you can see, it is a medium level problem and it has a lot of dislikes. Like, I think the ratio is not very good. It's below 1 or maybe below, like basically, this is not a good ratio. And why it has such a bad ratio and this problem is considered as not a good problem, and there's a reason behind it. But first, I don't want you to get this. Concept before even we start the problem that this is not a good problem. I want you to think that this is a good problem and we can learn something from it. And at last we will discuss after solving the problem that why it was not that much of a good problem and it has so many dislikes. Anyway, so let's start the problem. So the string that is PayPal is hiring is written in a zigzag pattern on a given number of rows like this. You may okay, so this is a string. PayPal is hiring. So this is a string. PayPal is hiring. Now we write this in a zigzag pattern that is P A Y, then P A L I S H I R I N G, and we are given and this is obviously this is written. This is if we have to read this string by after writing in a zigzag pattern, we will read it as P A H N, row wise, and then the second row that is A P L S I I G, the same way here, and YIR. Now we need to write a code that we need to complete a function, and this function takes two arguments, that is s and num rows. So s is the string that is given to us, that is PayPal is hiring, and num rows is the how many rows can that zigzag pattern have. So in this case we have three rows because this is one, second, and third row, right? It can obviously have like unlimited, like we are not capped on the thing that how many columns it could have, but we are capped on one thing, and that is how many rows this pattern could have. So we are given three rows and we are given this string, and this is the output, right? And we have to read this string as PA from the row traversal, and this is how we read this string. So this is the problem, and let's see how we can solve this. So first of all, yeah, let's work on this one. So let's say yeah, so this is the string and the string is PAY. Yeah, it should be capital. PAY PAL IS HIR HIRNG. And these are the indexes, right? So PayPal is hiring HIR, oh my god, HIRING. Okay, so these are the number of rows, and let's say we have, because it's a matrix and the pattern will be stored in a matrix in my implementation. So let's say this is the 0, 1, 2, and 3, and the num rows value, I will be saying it as nr, n dot r is equal to 4, right? So there are 4 rows, and in 0 indexing we will have 0, 1, 2, 3 row. Now how to do this? One way is just to simulate what the question is saying. The simulation is that we will keep a pointer here, and this pointer will keep on filling the rows, and when it has filled these rows, which means that we have another pointer, that is, let's say, current element, and this current element at this point is going to be 3, but after filling it will be plus plus, and that is 4. So when it is 4, then I can say that when current pointer is equal to 4, then it means we need to start fill up the elements in a diagonal manner, or in a direction that is top right direction, that is this direction. And when I will say this direction, I cannot fill the element at this point, which means I will not be subtracting -1. I'll be in fact subtracting -2 because I want to fill the element in the like if my current pointer is here, then 1, 2. I want to fill the pointer in this row. I want to fill the character in this row, that is -2. So current row -2, and then I'll be filling this character, but There's a difference. The difference is this is one column, this is another column, this is this column. So when I'm filling in this direction, my number of rows will be, so rows will be decreasing, column will be increasing. Okay, and the pointer, it has to increase because we are going in this direction. But when we are going in this direction, the number, so basically we are going in this direction, right? We are going in this direction. When we are going in this direction, now we are changing row, but we are not changing column, which means column will stay as it is and a row value will be increasing. Okay, so this is just a basic thing. Now let's solve this problem by writing a simulation code. So in order to simulate it, we have first condition, and that is if num rows is equal to 1, right? If you have, let's say, num rows is equal to 1, then you will be saying p. Now you cannot fill any other element. So a, then a y, then p. So this will be just nothing but the same string that is given to us as in the input. So if num rows is equal to 1, then you will be returning the string. Okay, now there are some variables. So n is equal to s dot size, that is total number of characters that we are given, that are given to us. Now there's another thing, and this concept is, so let's say this side we have one section. Okay, this is one section and this is the other section. Okay, this is another section. You can see how many elements are you know why I'm saying section, because this procedure of row plus plus and column, and then row minus minus and column plus plus, this would be done for every section. So if you have to guess how many elements are there in this, in each section, so we are very much sure of one thing, that in a perfect section, so let's say this is a perfect section, we have all the elements where they should be, we have a column, we have this column, right? Which means num dot rows elements will be there. That's a, like a, observable thing. And in this way as well, you will have num rows element, but p is already taken and we are not counting I, which means -2. So num dot row plus num rows dot no -2, -2. So if you have to write this will be 2 into num dot rows -1, because 2 is taken common, and this is the this is the total number of elements in each section. And if these are the elements in each section, then how many elements, then how many elements are, then how many sections are there? Then if each section has these many elements, then you will be dividing them by the total elements, and then you will get the number of sections. But you need a ceil value. Why? Because this is one section, this is another section, but this is also another section, right? We cannot discard any remaining elements. We have to like consider them as their own section. So which is why you have to take the ceil value. Now I will say section is equal to ceil value of n. Okay, divide by, now this is tricky, 2 into num rows that is given to you minus of 2.0. And why I'm saying minus of 2.0, because if it's because we are using a ceil value and I want a decimal value in order return from this division, because if it's an integer division, the ceil value will not be like helping much. But if it's a decimal division and then you have something like 3.4 something, then ceil will say that okay, we have a decimal value, so the integer value plus 1, that is 3.4, will be changed to 4, that is 3 plus 1. And that is why we need this section. Now another thing is num calls. Now num calls value is how many columns are there. So you will say sections multiplied by num rows -1. And how to count the columns? So yeah, so we have, this is a section, sorry, this is a column, right? This is a column. So you have, let's say, um so this is one column, and then you have, and in every section you will have a column, right? But there is a thing that is, yeah, so in matrix you will be storing them. in a way like this, right? We will be storing them in this way, and we need to have how, and we need to count how many columns will be there. So if you have, let's say, in this part you have this column. Let me just erase that. It's very hodgepodge now. Yeah, so this is one column. Okay, this is another column in which you have a, this is another column. How many elements do we have in this column? So in this section we have total 3 columns, which means if you have n num rows minus 1, that will be the num columns, which means this will be equal to, so total sections minus of, sorry, num dot r minus 1, sorry, multiplied, they should be multiplied, right? Because if you have 3 sections, then you will have 3 columns from each section and it will be multiplied with each other, and then you have total of 9 sections. So let's verify this formula for num column for this part. So you have 3 sections multiplied by n dot r, that is 3, sorry 4, but minus 1 is 3, so this will be equal to 9. Let's count if we have 9 section or not. So 1 2 3 4 5 6, and then you have 7. One, two, three, 4, 5, 6, 7. Yeah, I mean, we are neglecting this fact that we have a, like an empty, but in this way it will be 8 and 9, right? So this is a section that we are treating, but it is only able to fill these many elements, and it's better to have extra space rather than having no space for some remaining elements. So yeah, it's fine. So we can have a matrix that will have these many sections, and in order to have this matrix we need to have two things. So one is num rows that is given to us, and then we also need num columns. So they will act as a dimensions. So the dimension of the matrix will be num rows and num columns. Now let's create this matrix. So vector of, I'll say, character. This is a matrix that we want, and the rows is equal to num rows and columns is equal to num calls, and everything is initialized with star. So now you have a column as well. So now you have this matrix, and the dimensions of this matrix are num rows cross num calls. Okay, now you have another variables, and this is current row. So we are going to fill elements based on the current row that is initialized with 0. Then you have current column as well, that is also initialized with 0. Then you need a current string index, and that is also equal to 0. So after having all these variables set it up, now we can start iterating over the string and fill all elements into the matrix. So if the current str index is less than n, that is the size of the string, in that case we'll be iterating over the element. And okay, so the first thing is this column that we need to set. So let's just focus on one section. We will just forget about all other sections, just focus on one section. Okay, so in each section we have two things. So one is this part, this straight column that goes in the downward direction, and then you have this diagonal part. So for this one I will say downward direction filling. Okay, and for this you have this while loop, because you need to fill the elements in the downward direction. So current row value should be less than num rows, and the current string index should be less than n. Fine, if this is the case, then fill the elements in the downward direction. And how to fill them? I'll not be using parentheses. I'll say that matrix of current row. Now row value is changing, so I will say current row plus plus is equal to, not equal to, we also need to give a current column. Current value is not changing, so I will not be changing it. Equal to s of current string index plus plus. Okay, and then after that we have, yeah, after that we need to change some values, initialize the variables, pointer variables. Well, they are not pointers, literally pointers, but they are like index pointers. So pointer variables for the diagonal filling, and that will be, so current row, as I have told you earlier, it should be subtracted with 2. Why? Because now, so this pointer current row was pointing at this point, right? So this is 4, but 4 should not, but after that if we subtract only 1 from it, then we'll be filling the element here, but we don't want to fill the element here, we want to fill the elements one step back. So which means it will be not just -1, it will be -2. So this will be equal to current row -2, and that is what we are doing. We are decrementing 2 from the current row variable, and current call will be incremented. And why it is incremented? Because we need to shift to the next column. Now I'll be doing a diagonal filling. So the diagonal filling will be a while loop again, but this time current row should be greater than 0, because we are decreasing the row and we need to make a check that we are not going into the next section, because this row value of 0 does not belong to the first section that we are currently working on. So we need, it has to be greater than 0, not even equal to 0. Yeah, no, it can be actually equal to 0, but it cannot be greater than 0. And then you have current column as well, because current column will be increasing, and current column has to be less than num calls, the matrix column. And the last thing is again the same one, current string index has to be less than n. So after this value I will say mat of, yeah, so current row is decreasing, current column is increasing, and s of, and current string index is also increasing. Yes, I think this is good. Now we need a string as answer, initialize with empty character. So now let's iterate over the string, over the matrix actually. So this is equal to num rows, num calls. Now I will say if character, if not the character actually, if mat of I j is equal to a star character, which means that we have get all the elements and now we can break. Other than that, we will say answer plus equal to the mat of I j. And after having this value, we can return this value. Okay, so section. Yeah, I think it should be ignored. If it is equal to it, I'll not break actually, I will say continue. Yeah, now it's working. So let's see if this will be submitted. Okay, it is submitted and it is performing very bad. So let's see if there's any better option for this. Okay, now let's understand some few of the things. Okay, so there's another approach where we don't have to worry about the you know the matrix, where we can simply get our answer based on some of the observations and some mathematical things. So this is 0, 1, 2, 3. Okay, so the observation is, after p we want I, but we want which I? We want this I, don't we? And for a, after a we want this L. So what is this relation? So let's see, if I want p, after p I want I, but from a we want L, from y I want a, from after p I want I. So there's a thing that is, for every top and bottom row I need the next element to be the other section's element, but for all the rows that are in between, that are not top and bottom, for them then their next element can be found in the same section, right? Because a and l, they belong to the same section, right? So this is a section and a and l belong to the same one, y and a belong to the same one. Now how to figure out, like, their, after, what is the gap between them in the main string? So let's observe few of the things. So first of all, how many characters are there in the section? As we have, you know uh, like, taken the look at the formula in the previous approach, so that is equal to n dot r minus 1, 2 multiplied by n dot r minus 1. So these are the characters in each section, or, good to say maximum character, because this is also a section but we don't have 2 into n into r minus 1 characters in it. So maximum characters could be 2 into n minus r. Okay, now the other thing is, so if you don't have, let's say you are on currently you are on this character that is 0, so after p you will say, like, pass all the characters, after all of them, these characters, you will have I. But how to understand, how to get this value that you will have I? We need to do something, that is, so a, y, p, a, l, these are all the elements, right? So we can have these, you know because this is like one section. Yeah, this is one section. So you will basically say that, so characters in section, that is total characters in section, this value minus of, characters in between, how many characters are there in between these values. These are the characters in between this value. How to get this value? So you will say, um okay, so let's say that you are on this 0th row, and obviously you have included p already, but now you need I. So you will not be taking this element. Fine. So you'll be saying that, um, these elements and these elements should be taken into consideration or should be skipped, and you need to count them, how many elements are there. So you will say num dot rows minus 1, num dot rows minus 1, because it's a zero based indexing, that is why we are subtracting 1, and minus of current row value. Why are we minus current row value? Because we have already taken it. And again, this is like one thing, and then you need to take value for this one as well. So you will say n dot row minus 1 minus of current value again, right? And okay, but this is different. Why it is different? Because in this case you are over counting p again, and we need to subtract 1 from it as well. Okay, but this is also different because we have to, push the element again, and that's a later part. So I will say this is the remaining characters that are meant to be skipped. I will say characters that should be skipped. So if they are skipped, so the formula will be something like this: 2 into n dot r minus 1, these values, minus of 2 into current value minus 1. And what is this value, if you can remember? This is the characters in each section. So characters in each section minus of 2 into current minus 1. These are the number of characters that are in between the string, and you can verify it as well. So total number of characters in each section is 1 2 3 4 5 6. So we have 6. N dot c e as number of characters in each section is equal to 6. Okay, and 6 minus 1 is going to be 5. 5 into 2 is going to be 10, minus of 2 into current minus 1. So 2 into current row, that is 0, and minus of 1, so this will be equal to 7. Okay, so after this point 0, you'll be like 1 2 3 4 5, sorry, 1 2 3 4 5, and this one as well 6, and this is 7, and this is working. And yeah, you need to subtract 1 from it as well. So this is now equal to 1 2 3 4 5 6. Yes, the elements that are need to be skipped, and then you will find your I. Okay, so this is all, this is it. And if you happen to be in these rows, then you need to count the element by subtracting the elements that needs to be skipped, that are these ones. And this is simple, you can obviously do it. So yeah, let's get to the coding part. So I will reset this one. Yeah, first thing first, the condition that we need to check, if num rows is equal to 1, then we need to return the string as it is. Now string have an answer. The other thing is int n is equal to s dot size. Then you have character, let's say chars in each section is equal to 2 into, as the formula that we have devised earlier, num rows minus 1. Okay, now we will be iterating over each row. So let's say current row is equal to 0, because it's a 0 based indexing, so it will be less than num rows, and current row plus plus. Fine. Now you need an index, and index is equal to current row. Now while index is less than n, and that is the condition, like we cannot go like if we have current row value, like it cannot be greater than that, but it's good to have this condition. And index is actually changing. Why we are doing this? Index is equal to current row, because index will be iterating. So this is something that is iterating over the string index, and the current row is which we are this arrow that we are iterating over this current rows. So at first case, I will say answer plus equal to s of index, right? Because that element is added, and I'm now done with it. Now if it is a let's say the first element, right? So this is the first element. Actually I have explained you this process, but this process is only like will only take place for these rows that are not top and bottom. But for the top element, we are just fitting the element and then forgetting it, because the I is in the next section and we are not worried about it. We don't want to have it. So I will say if I have the p, because this is a 0th row, if I have p with me, I can simply go on and I will say index plus equal to all the section, all the these characters in a section should be added into it. So characters each section, right? But the thing is different if you have, if the current row is not the top or bottom row, then things will be different. And how they are different? So we need to check if current row is not equal to 0 and current row is not equal to num rows minus 1, that is the last row or the bottom row. If this is the case, then then it is the row that happens to be in between of the top and bottom row. So now you have some formulas and we'll see them. So these are the formulas that will take place right now. So you have characters that should be, oh damn, that's a very bad naming, but okay, but just for the concept, right? So characters that should be skipped. So this is equal to characters in each section minus of, now how to devise this formula? So I have the characters in each section minus of 2 into, minus of 2 into current row and then minus 1. Okay, after this, okay, so let me give you a good example, because earlier I have given you, like, this example is also fine because you can connect the dots with these cases, but let me give you this. So if you have, let's say you are, yeah, so num rows and the current row is equal to 1. Okay, so if it is equal to 1, then 2 into 1 is going to be 2. Now num rows is equal to, 2 into num rows minus 1, this is equal to nothing but 4. Yeah, 4 minus 1 is going to be 3. 3 into 2 is 6. So 6 minus of 2 minus of 1. So this is 6 minus 2 is going to be 4, minus 1 is going to be 3, which means 3 characters should be skipped. And it's good, because why? There are 3 characters as well, 1 2 3, that should be skipped, right? It makes sense. So if I'm at A and I say that 3 characters should be skipped, which means Y, P and A, they are skipped. Now we are at L, right? For that I have to add 1. So I will say the int second index is equal to characters that should be skipped plus 1. Okay, because we need to move to the next element, and if we just add the characters in, that should be skipped, then we are at 4, but we need to be at 5. So that is why I'm adding 1. And then I will say, now there's a condition, if second index is greater than n, then we are not going to do anything, we are not going to add anything, because that's like a thing, that we have a large matrix but we are not using it, but some of the elements there can be remaining elements in the last section, and we don't want that remaining elements, right? Like, we want the remaining elements, but we don't want the empty elements that are not in the string. So if it is less than n, only then we are going to make our processing, and the processing answer is plus equal to s of second index, right? Now at last I will say return the answer. Okay, should be current row. Yes, and we also need to add the index, right? Because if we are on this index, then we need to add them. Yeah, so this was the issue. I think it should run. Yes. Let's try submitting it. Yes, it is submitted, and it's not performing that bad as compared to the earlier, simulation approach. And on the space as well, it's performing good. On the time as well, I think it could be even better. Yes, now it's good. So yeah, this was the problem, and now, as I have told you, that we are going to discuss it why it's not a good problem. Like, we have solved this problem, right? Can you really observe that we have not learned anything from this problem? We haven't learned anything. It's not data structure, right? It's not a data structure problem. That's like 100%, like, that's we all know. And we haven't learned maths as well. Like, it's a basic math. It's not like something that, that involves percentages or modular operator, or some smart like IQ level maths, nothing like that. And I think it's just an ad hoc problem, and LeetCode is such a reputable platform because even a beginner can solve some data structures problem. And that is why it's very different from competitive programming, right? Because in competitive programming you have ad hoc problems, you need to have problem solving aptitude in order to solve some problems. And having a good data structure is like a good thing, but problem solving capability is more preferred when we go to competitive programming. But in this case, LeetCode, even a novice can solve a data structure problem because they are designed in that way. And this problem does not help at all in any case. So that is why I personally don't like this problem. A lot of people don't like this problem. Even I wasn't giving on my first, like solving this problem, when I was solving this problem on the very first day, I wasn't giving attention that how many dislikes are there. I just saw that there are good number of likes, because in most of the lead code problems there are like 100 dislikes. So I just ignored that and I saw that that's a good problem. But after solving this, I was like, this is not a good problem. I'm not enjoying solving it. And yeah, so this is the problem, and hopefully you have learned something. Although the problem is kind of okay. If you want to look at the source code, it's given in the description. Both of the approaches are given in the description. If you want to try this problem yourself, the link is also given in the description. Thanks for watching and have a good day.